Hello everyone, in this video we'll be covering solution for question 6. So let's see first part of this question, which is describe how the coefficient in linear regression are estimated using either the closed form equation or gradient descent. Now let's see the solution. Consider linear regression with n observation. Consider linear regression with n observation and p features, where x is n by times p design matrix, beta is parameter vector. So first is closed form solution. We minimize the sum of squared errors. Then taking derivative and setting to 0 gives beta equals to this, assuming x of x is invertible. This directly gives optimal coefficient but can be expensive when p is large. And in gradient descent, we first initializes beta, example 0, repeat until convergence, beta equals to beta minus alpha partial j partial beta, where alpha is learning rate and partial beta is this. Stop when change in beta is very small. Gradient descent scales better to large dataset and also works when closed form is not convenient. Now let's see next part of this question, which is explain logistic regression and use the logistic function to calculate the probability of class for given input example. So logistic regression. Logistic regression is a classification algorithm that models the probability of a binary outcome y belongs to 0, 1 given features x. It uses the logistic sigmoid function, because of which the data is in between 0 and 1. So its formula is p equals to 1 upon 1 plus e to the power minus z, where z is w by uh, seed x plus b. Decision rule. It predicts class 1 if p is greater than 0, else class 0. Example, suppose for a single feature x, we have w equals to 0.8 and b equals to minus 1. For x equals to 2, z will be 0.6, which is greater than half, so the product predicts class 1 with probability about 0.65. So this is it for question 6. We'll be covering next question in another video.